We're going to continue on in chapter 6, lesson 3, the idea of converting things from one measurement to another. Now, some of the problems that we're going to have is we have some attitudes, we have people getting upset because we're just not wanting to watch the videos that I'm making for you, even though they're there for you to benefit and be able to rewatch and have me teach you over and over and over again until you get it, and you're not wanting to pay attention. And then when you come to do your assignments, you can't answer the basic questions. How do I set up the problem? Well, until you watch the video and you pay attention enough to be able to answer that basic question on these lessons, I'm not going to sit down and reteach it to you. You have to be able to answer the basic questions. How do I set it up? And it's always the same format every single time. This lesson in chapter 6, lesson 3, we're not going to be dealing with the other two that we've already talked about. Now we're going to be dealing with mass and weight. Remember, there is a difference between mass and weight. Mass is the amount of space a body takes up. Weight is the amount of gravitational pull on an object. And that's really where we're going to focus. We're going to have our basic translations of measurements called the standard or the customary units. We have pounds and ounces and tons. But we're also going to have the metric system. And once again, if we can remember, King Hector doesn't usually drink chocolate milk. That helps us do those. Now, I've already graded about 6 or 7 of the chapter 6 lesson 1, and here's what I'm seeing. I just don't want to show my work. We're falling back into the original bad habits that we had the first 3-4 weeks of school, where a lot of our math grades were not very good because we aren't showing labels, we aren't showing work, and we're just writing down answers. I can't give you full credit for that. If you give me all right answers and no work and no labels, you're going to get less than 50% because every question is worth 3 points. And that's why I show you all my videos, every step that I need to see and every part of the answer that I need to see. Using our customary weight conversions, once again, we have 1 pound is equal to 16 ounces. And we know that in tons, 1 ton is the same as 2,000 pounds. In the conversions for the metric system, it's just simply the same setups. We have our kilograms, which going backwards, kilograms, hectograms, decagrams, grams, decigrams, milligrams, centigrams, all of those and our basic conversions. They may not give us all the conversions we'll need to use in our setup, so we may have to know the steps in order to move it to the right, to move it to the left, how many zeros are behind the 1. Our setup is the same as it has been on 6.1 and 6.2. Knowing what I'm starting with, knowing what I'm going to. What I'm starting with will always go over 1. What I'm going to has to be the label on top. My conversion label then has to be the matchup of what it's equal to with the what I'm starting with label on the bottom. That's how it's converted because I can cross-reduce the labels, which makes it automatically have what I'm going to as the new label. So let's get into our setup. Our first scenario is talking about the largest pearl that was ever found. The largest pearl ever found weighed 226 ounces. What was the pearl's weight in pounds? You and I don't talk about, well, hey, how many ounces do you weigh? We usually talk about pounds. Well, I have to be able to convert that. So how do I know what conversion to use? Well, my conversion is always what I'm starting with ounces. And then what am I going to? Well, what am I going to? I'm going to pounds. So I know pounds has to be on top. What conversion factor or conversion rate would I use? Well, I have to use the one where pounds is on top. And I know that 1 pound, which would have to be on top, is the same as 16 ounces, which therefore the 16 ounces has to be on bottom. That's going to be my conversion factor or my conversion rate that I use. How do I know it's that one? Once again, what I'm going to has to have that label on top. I'm going to pounds, my pounds has to be on top. What I'm starting with has to have that label on the bottom. I'm starting with 226 ounces, so ounces has to be on the bottom. It allows me to cross-reduce them. So we have the setup, or the original setup that they've given us. We're going to cross-reduce, we're going to convert our labels. If the ounces is on top and ounces on bottom, I can cross those out, which leaves me with the conversion of the pounds. So what I'm left with is I'm going to have 226 divided by 16. Because when I multiply across, I get 226 times 1 pound, which is 226 pounds. And on the bottom, I'd have 1 times 16, which is just 16. A fraction tells me to divide. So when I divide 226 by 16, I get 14 with a remainder of 2. My remainder of 2 is my numerator. My divisor of 16 is my denominator. And then I would reduce it. But since I'm dealing with pounds and ounces, I don't reduce it because it's not looked at as just a normal fraction. I'm just going to keep it as, well, then I have 14 whole pounds, and out of the ounces that are left, I know that I have 2 ounces. So it would just be an answer of the pearl weighed 14 pounds, 2 ounces. That is bigger than your average newborn baby. That's got to be a pretty big pearl. So the largest pearl weighed 14 pounds, 2 ounces in our conversion into our standard or our customary measurements. Well, if I go to this idea then, but instead of a pearl, I'm going to talk about an emerald. This emerald is a green rock that is crystal-like, and therefore it's translucent and allows light to go through it. The largest emerald ever found weighed 38 pounds. So now I'm going to go to pounds, but it says, what was that weighed in ounces? So I'm going to go in the opposite direction. What is my conversion factor or my conversion rate that I'm going to use? Well, I'm starting with pounds, but I want to go to ounces. So pounds has to be in top, pounds has to be in the bottom, so I can cross-reduce and convert. That means ounces has to be on the top. So I'm going to flip what I'd had before. Instead of being 1 over 16, I need the 16 ounces on top, and therefore 1 pound on the bottom. If I have that in my setup, which is on the next line in your book, then I see that my pounds are indeed diagonal one to another, and I can cross-reduce those. That's why it's called the conversion part, because it changes it, therefore, into ounces. When I have just 38 times 16 ounces left, then all I have to do is multiply across. This is going to be the opposite way, so I don't have to divide this one, I just need to multiply. 38 times 16 is 608. 608 what? 608 ounces. Now, as some of you are going to find on chapter 6, lesson 1, your answer line, as I tried to warn you on the video, doesn't give you the labels. You have to have the labels. It's worth 1 point. This one has the label, this one has the label, so I know I'm good. But on your answers, in your assignment tonight, you have to make sure your labels are there. Well, look at question 1. Explain how you can convert the emerald's weight to tons. Wow, tons. Well, that would be a pretty small weight. However, if I know how many pounds it was, which is 38 pounds, and I know that 1 ton is the same as 2,000 pounds, then I would have to have pounds on top and pounds on bottom, which would give me 38 over 2,000. So that would tell me that I would end up dividing 38 pounds by 2,000 pounds to tell me how many tons that would be. It would be a decimal point, but it's not asking you to solve for the problem. I don't need you to do that. I just need you to understand that if I was setting that up and I'm starting with pounds and I'm changing it into tons, pounds would have to be on the bottom. So that would give me, when I cross-reduce my labels, I'd end up with 38 over 2,000, so I'd have to divide. All right, let's look at the second example they give us then. This is the amount of matter in an object. It's called the mass. So this is our mass measurements when it comes to the metric system. Metric units of mass are related by the powers of 10. So we know that if I go to the right, I'm moving my decimal point 1 time. So that's what it means by powers of 10. And if I'm going to the left, I'm moving my decimal point 1 time to the left. When I think about my conversions, and I think about King Hector, and it makes it a lot easier on knowing which way I'm moving my decimal. But it says on this one that Corinne caught a trout with a mass of 2,570 grams. What was the mass of the trout in centigrams? What was the mass in kilograms? So I have 2 different conversions that I have to do. So when I go just from grams to centigrams, I have to know which way I'm going. Well, grams is, once again, my unit measurement. Doesn't usually, that's my unit measurement. So there's grams. Drink chocolate. Chocolate is my C, that's my centi. So I know I'm going 2 steps from the key, so I'm going to the right, which means I'm going to move my decimal to the right. If I look at my setup, it says, well, I'm going to use the idea that there are 100 centigrams for every 1 gram. Well, how do I know that? Well, when I go up to my chart here, it says 100 centigrams is the same as 1 gram, so that tells me which one I'm going to use. If that's the one I'm going to use, how do I know which one has to go on top versus which one goes on bottom? It's all based on what I'm going to. I'm going to centigrams, so my centigrams has to be on top. I'm starting with grams, so my grams has to go on bottom. Once I know that I'm going to use my 100 over 1, then my setup is already here in my book. I have my 2,570 grams. I have my 100 centigrams over 1 gram, which they show you you're cross-reducing the labels, and I'm just left with multiplication. So I can type into my handy-dandy calculator 2,570 times 100, or I could look at it as my steps, and I can move my decimal 2 times. There are 2 zeros when I multiply by 100. I put the decimal at the end of my whole number. Since I'm multiplying, I'm going to the right. I move it 2 times, add 2 zeros to the end. Either way, I'm going to find out that 2,570 grams is the same as 257,000 centigrams. Am I done? No, because I had 2 questions. Now I have to convert it going the opposite way into kilograms. So if I'm going to change it into kilograms, then I'm going up the steps from grams. 1, 2, 3. Notice I showed you the little loops. I'm moving that direction to the left. If I have 2,570, how many steps do I go to kilograms? Well, I'm going to go a total of 1, 2, 3 grams. Which way am I going to go? I'm going to go to the left. If I want to set it up in my conversion setup, then I notice here it tells me at the bottom that 1 kilogram, which is what I'm going to go to, is the same value as 1,000 grams. So I have what I'm going to, kilograms, over my grams, which is what I'm starting with. So when I set it up, then I know I'm going to take my 2,570 70 grams on top. I'm going to have my grams on bottom so I can convert my labels. Leaves me with 2,570 divided by, because I'd end up with a fraction. If I divide by 1,000, it's the same as saying, well, I know I'm going 3 steps to the left. 1, 2, 3. I'm dividing because I'm going to the left. If I just show there are 3 zeros on my 1,000 and I move my decimal to the left 3 times, then I know that it's going to be 2.57. Notice I didn't say the 0 at the end. It's kind of like some of you a couple lessons ago on one of your money answers, you had, I think it was $15.5. Well, that's not a number, not in money. That's 15.50. I have to have the 0 in money. But if it's not money, I don't put the 0 at the end of my decimal numbers. So I have 2.57, and that's it, kilograms, by either dividing or by moving my decimal. If I don't show one of these ways of doing my work, I can't get credit for doing my work, and therefore I'm going to miss a point. I can have the correct point for my answer. I can have not have a point for showing my work, and then I got a 50% on this question. No reason I have 50% when all I have to do is show which way I did it to get that extra point. Well, let's look at this one. This is just a made up like a Dr. Seuss math problem, and we have to think about what it's saying. Suppose hoots and goots are units of weight, and 2 hoots equal 4 goots. Which is heavier, a hoot or a goot? Explain. See what I mean by it sounds like Dr. Seuss? Well, you could give me 2 answers. It depends on how you would want to state it. You could either say, well, a hoot would be heavier, or you could say a goot would only be half of a hoot. Well, either way, you then have to tell me how you know. Explain how you knew that. Well, I know that because it tells me that if 2 goots are needed to make 1 hoot, because 4 goots makes 2 hoots, so that means 2 goots would have to be used for 1 hoot. So there has to be 2 to make 1 hoot, and therefore either a goot is half of a hoot, or a hoot would be heavier than a goot. Dr. Seuss all over again. All right, so we'll get to our practice problems. We're going to go from pounds into ounces. That means we're going to use our customary weights. I know which one I'm going to go to because I'm changing it into ounces, which has to be on top, and my pounds has to be on bottom because that's what I'm starting with. So it tells me if there's 1 pound, it has to go on bottom. 16 ounces has to go on top. Well, I know that my answer is going to be 144 ounces. How do I get that? Well, I had my 16 over 1 as my setup, and when I cross-reduce pounds, I'm left with 9 times 16. And when I have 9 times 16, then I have 144 ounces. On number 2, going from grams to decagrams. So I have 3.77 grams times decagrams. Well, what's my conversion for decagrams from grams? Well, it says that 1 decagram is the same as 10 grams. So if I know what the conversion rate is, I just set up what I'm going to, decagrams, DAG, what I'm starting with on the bottom. So my 10 grams has to be on the bottom. Lets me cross-reduce and convert my labels into decagrams. And then all I have to do is divide. Or I could simply say, well, I know according to my steps with King Hector, I'm going from grams and I'm going up 1 step to the left. 1 0 to the left tells me they have 0.377 or 377 of a decagram. 377 thousandths. I don't think it said thousandths there. On question 3. Amanda's computer weighs 56 ounces. How many pounds does it weigh? So I have to know what conversion rate I'm going to use again. I'm starting with ounces. My ounces has to be on the bottom. What I'm going to has to be on the top. So I know I'm going to go change it into pounds. How many pounds are there per ounces? There are 16 ounces per pound. So I know I have to put the 16 on the bottom, the 1 pound on top, which tells me to take my 56 and divide it by 16 to see how many pounds there are. I can cross-reduce my labels and get rid of them. When I multiply across, I'm left with 56 over 16. My pounds labels on top. If I have 56 over 16, then I know it's division. Any fraction is division. I take my top number, put it inside my box, divide by my bottom number. So the numerator is divided by the denominator. 16 goes into 56 3.5 times. So I know 56 ounces is the same as 3.5 pounds, or you could have done it as a mixed number. You could have seen that you had 8 left over, and 8 over 16, which is my divisor, tells me the same as 3.5. Either way, those are correct answers. 3.5 pounds or 3.5 pounds is your correct answer. And then on number 4, it says a honeybee can carry 40 megagrams, or milligrams, excuse me, of nectar. How many grams of nectar can a honeybee carry? So milli up to grams, milli, centi, deci, grams. That's 3 steps. Or when I look at my charts, it tells me what my conversion rate is from milligrams to grams. It's 1,000 for every 1. So if I start with what I have, which is 40 milligrams, and then what I'm going to, according to the chart, I'm going to milligrams or to grams, so I have to put the milligrams on the bottom. So for every 1,000 milligrams, there's 1 gram, what I'm going to on the top, cross-reduce my labels. I'm with 40 over 1,000. Once again, a division problem. If I simply set it up as 40 divided by, there were 3 steps, so the 1 has 3 zeros on it, divided by 1,000, I know I'm going left. I'm starting at milli and going up to grams. I'm going to go see the king, so I feel smaller, smaller, smaller the closer I get. Then I move my decimal 1, 2, have to add a 0 to hold that place value to get a 3rd time. When I put down my answer, though, once again, I only keep a 0 at the end of a decimal number if it's holding the hundredths place on money. If it's not a money problem, if it's not holding the hundredths place on money, I get rid of that 0. So it's just going to be 0.04 or 4 thousandths of a gram. All right. So if I look at number 5, 6, and 7, same type of process. What we're doing, changing from one into another. What's my setup? My setup once again is, what am I starting with, times what I'm going to over the label that I'm starting with. 4 pounds going into ounces. I know that the pounds has to be on bottom so they can convert and cross reduce. The conversion is when I keep my what I'm going to label on top, so ounces has to be on top. When I get rid of my pounds, I'm left with just multiplying 4 times 16. And 4 times 16 gives me 64. So I know that 4 pounds is the same as 64 ounces. Grams to centigrams. So if I have my grams and I go to centigrams, that's 2 steps to the right. So if I'm going 2 steps to the right, it's the same. If I look up here, it tells me there are 100 centigrams in 1 gram. So I know my centigrams has to be on top of 100 and grams on the bottom. That would let me cross reduce and multiply those two, or I could just simply move it by multiplying it 2 times, means I have, or multiplying by 100 means I have 2 zeros, and I just move it to the right 2 times. Either way, multiplying on my calculator once I set it up, or just moving and shifting my decimal 2 times to the right, gives me that 7 13/100ths of a gram is the same as 713 centigrams. And now I go to a T. Where's a T? I don't have a T, do I? So I may have to look at some other conversion rates and see what that T means. Oh, well, that T actually means tons. So what happened last year is when we did this problem, I had a whole bunch of people changing this into teaspoons, and they got a really crazy answer. Or not teaspoons, but tablespoons. So there is a capital T on tablespoons, but it's always TBS for tablespoons. A capital T by itself is just tons. I mention that because in case any of you cook with your parents or grandparents like I always have, then a T on recipes often means, a big T, just means a tablespoon. So please don't get confused. In mathematics, they're going to show you the TBS. This is just a tons math problem. All right, so once I know that I'm going to tons instead of tablespoons, then I know I'm going to have for every 1 ton, 2,000 pounds. 2,000 pounds has to go on top because that's what I'm going to, and I'm going to be able to cross reduce my tons. So if I have 3 tons and 2,000 pounds is 1 ton, then I'm just going to multiply 3 times 2,000, and that tells me that I would have 6,000 pounds if I have a 3-ton load. 8 and 9, story problems, like you're going to see at the bottom of your homework assignment. The African Goliath frog can weigh up to 7 pounds. How many ounces can the Goliath frog weigh? So what am I starting with? What am I going to in my setup? I'm starting with 7 pounds. I'm going 2 ounces. So the ounces has to be on top and the pounds on bottom. We know that for every 1 pound on bottom, that I have 16 ounces going on top. So I put the 16 over 1, cross reduce my pound labels, and be left with 7 times 16. 7 times 16 tells me, when I multiply them then, that it's 112 ounces. And then number 9, the mass of a standard hockey puck must be at least 156 grams. What is the minimum mass of 8 hockey pucks in kilograms? So I have to do a first step there. And look at what I'm starting with, which is 156 grams. But I can't just jump into changing that into kilograms. I have to realize that I'm going to have 8 of them. So I have to take my 156 times 8 to see what I'm starting out with in my grams, which is 1,248 grams. Then I can change that into my kilograms. And for every 1 kilogram, which is going to be at the top, I'm going to have 1,000 grams. because that's what's up here on my chart. When I know what my conversion rate or conversion factor is, kilograms on top, grams on the bottom, then I know that I'm going to be multiplying across. After I reduce my labels, I'm left with 1,248 over 1,000, which once again is division. Or if I just say, okay, I'm going to be dividing by 1,000, that is 3 zeros after the 1, so I'm going to shift my decimal 3 times, then I get 1.248, 1 and 248 10,000ths of a kilogram. Have to have that label on there in order to get the credit for the label. All right, so that takes you to the last 3 that we're going to be doing together. I want you to do these on your own. Look at it. Once again, just like on the previous 2 lessons, you can do either way because I'm going to show you both ways. On 6.1, out of the 6 of you that turned it in, 4 of you didn't show me any work at all. You just showed me either greater than, less than, or equal to signs. That doesn't give you credit. Okay? You can't prove to me that you knew what you were doing. You either copied or you guessed, because I don't have any work to show me that you understood what you were doing. You have to show me one of the 2 problems I'm going to show you. So do it in your book, practice it, pause the video, come back when your answers are written down, and I'll explain how you get your answers. So I can only hope that you have done as I've asked, and you pause the video, you work through these 3, and then you can check your answers and make sure you're on the right track and understanding what we're doing. So we're going to have our pounds, and we're going to change it into tons, or we're going to take our tons and change it into pounds. Either way, I don't care. I'm going to show you both setups. So going from my pounds to tons, what I'm starting with, pounds, going into, at the top, tons. I know for every 1 ton, it's 2,000 pounds. So I'd cross-reduce my labels and be left with 250 over 2,000. When I divide that, because a fraction is indeed division, 250 divided by 2,000 would tell me what I have. Well, if I want to go instead from tons to pounds, and I start with the 0.25, 25 hundredths of a ton, multiplied by what? Well, I have to multiply it by pounds because that's what I'm going to. It'd be 2,000 pounds over 1 ton. Cross-reducing it just leaves me with multiplication. Either way that you did it, you just type it into your handy-dandy calculator, either 250 divided by 2,000 or 25 hundredths, 0.25 times 2,000, are going to show me that this one is equal to 0.125 tons. 125 thousandths of a ton. And this one is equal to 500 pounds. Which one shows the way the arrow should be pointed? 250 compared to 500 or 0.25 compared to 0.125? Well, I would see that 250 is definitely smaller than 500. If I added the 0 at the end of the 25, comparing 0.125 to 0.250, that is still showing me that the arrow is going to point to the 250 pounds. That is definitely smaller. Arrow always points to the smallest number. 11. So you could have either gone from hectograms to decagrams, or gone from a decagram to a hectogram. Either way, as long as you show me your work, I don't care which way you do it. As long as you show me your work and get the right answer. So let's see what we could have done. Going from hecto to deca or deca to hecto. I'm either going to go down 1 step or up 1 step. So I'm either going to shift or I'm going to divide. 65.3 hectograms times my 1 decagram. Tells me the hectograms on the bottom, and I'm multiplying by 10. I'm just going to shift either to the right or I'm going to shift to the left. So if I did this one, I'd be shifting to the right, which would tell me that this is equal to 653. If I shift this one to the left, because I'm going from decagram up to hecto, which is going up 1 step, then I have to move it 1 time to the left, which is 65.3. What that shows me is these two match, So either way that you did it, you should have gotten an equal to on question 11. Well, then I go at number 12. I'm going to have a tons to a pound problem once again. 5 tons to 5,000 pounds. Well, if I go from 5,000 pounds, starting that on top, and I'm going to tons, it has to go on top. I have 5 divided by 2,000. Well, 5,000 divided by 2,000 is not going to give me 5. But if I wanted to go from my tons, which is my 5 tons, and change it into the pounds, then I would put the 2,000 pounds over 1 ton, and that's going to let me multiply. And that's going to give me more than 5,000 pounds. Because 5 times 2 is 10, so I know 5 tons is the same as 2,000 pounds. Or if I divided 5,000 by 2,000, I'd get 2.5 or 2.5, either way that you did it, 2.5 tons. I know that this is smaller than this. So my arrow is going to point to the right. So that wraps up our conversion rates. In the next two lessons, I believe, are going to be talking about using those conversion rates and figuring out some information. But this is our last practice set for homework. This is chapter 6.3, page 331. You have 2 through 10. And then on the back, you have 1 through 6. Once again, 1 and 2 are going to be looking at changing mass and weight. And then 4 through 6 is going to be reviewing the things that happen between chapters 1 and the last 2 lessons in chapter 6. So if you have any questions, if you've paid attention, you're able to answer the setup questions, come back and ask, and I will help you.